Now we talk about unit ramp signal. Obtained by integrating the unit impulse function twice or integrating the unit step function once. During continuous time domain, the ramp signal represented as Rt equals to 0 when the t is smaller than 0, t when the t is bigger or equal to 0. It represents in a straight line. Let's say y equals to mt plus c. So this m is equal to 1, c equals to 0. Substitute into this equation, we will get y equals to x. Okay, so this y will be represented as Rt and x will be represented as t. So this happens during the time is bigger or equal 0. So this is our functions. Okay, now we draw the signals. So this signal will be look like this. We have a Rt and our time in t. Okay, so start from 0. We need 1, 2, 3. So it will multiply with t. The signal will be like this. Okay, so this is also 3, 2, 1. Okay, so the angle of here is 45 degrees because when m equals to 1 equals to tangent 45 degrees. Now we go to the discrete time domain. So this signal will be represented as Rn. It will be equal to when 0, the n is smaller than 0, and t when the n is bigger or equal to 0. So the signal will be look like this. R N so 0, 1, 2, 3. Same for here. The signal will be 1, 2, and 3. This is the discrete signal. Okay, now we go to the property of this ramp signal. First property, we will look at the relationships unit ramp versus unit step. Just now we said that unit ramp signal is the integrating of unit step function once. Okay, let's see. We have a Rt is equal to integrate negative infinity until time t unit step signal dt. Okay, this unit step signal, when we integrate, so we integrate negative infinity until 0, we get 0 because our unit step is 0 when the negative time, and plus with the unit step from 0 until a time t, we will have 1 dt. Okay, so we will get this 0 is a unit step in 0. So this is 1, so we will get t, or t multiplied with 1. So we can see here our Rt is equal to our t, okay, multiplied with our ut. Okay, this can be shown that our ut, we want to become a Rt, we need integration. And we want to find back is a unit step in differentiation. Okay, so this is the relationship between RT and XT. We want to determine our ramp signal whether it's an even or odd signal. So this is our ramp signal. So to determine whether it's even signal, we will have R minus T. To obtain R minus T, we have to fold the RT signal at y-axis. Fold at y-axis. Okay, so this is our signal. We fold at y-axis, we will obtain a signal from right-hand side, become left-hand side. So this RT signal is not equal to R minus T. So prove that this is not even signal because both are not same. Now we want to determine whether it's an odd signal or not. So we have to fold this R minus T signal at T axis. So we have a minus R minus T signal. Now we folded from this upright here to down here. Okay, so when we see whether this signal same as our signal or not. So not. So minus RT is not equal minus R minus T. Okay, so this is not odd signal. So as a conclusion, from these two, we can obtain a conclusion here. This ramp signal is neither even signal nor odd signal. Okay. Now we want to determine our power and energy. Whether this ramp signal is power or energy signal. How we want to determine? So we have the formula. Power P equals to limit T nearest to infinity 1 over 2T bracket. Now you want to integrate our ramp signal dt. Okay, we want to integrate this signal from negative T until T. Okay, how we do? So let's see. Limits T until minus T 1 over 2T. So now we have to integrate the first part from negative T until 0. We have the signal at 0, no signal. Then plus with when from 0 until T, we have a signal of T square dt. Okay, so we integrate this signal. We will have limits T until infinity 1 over 2T. Now we have 0 plus with when T is integrated power of 2, so we will get T power of 3 divided by 3. Okay, we multiply inside. You will get limits T nearest to infinity. So we will have this T cancel off with this T. We have power of 2. So T power of 2 divided by 2 times 3 is 6. Okay. Now we substitute the infinity value inside. So limits. So we will have, okay, so we will have T becomes limits square divided by 6. So if maximum infinity value is divided by 6, we will get infinity. So our power is equal to infinity. Okay. So our power will become infinity. Okay, now we want to determine whether ramp signal is an energy signal. So we have a formula. Energy equals to integrate from negative infinity until infinity modulus xt square dt. Okay. Now we integrate our ramp signal from negative infinity until 0. So our ramp signal will get 0 dt. Plus with from 0 until infinity, our ramp signal will get t square dt. So we integrate it, we will have t cubed divided by 3 from 0 until infinity. So we can substitute our infinity, power of 3 divided by 3, and minus of 3, 0, power of 3 divided by 3. So what we get here is infinity minus 0. So we also obtain our energy is infinity. So when power is infinity, energy also is infinity, this ramp signal will be neither power nor energy signal.